So in this video we're going to use the method of undetermined coefficients when our driving function is a cosine or sine. So we have a second order non-homogeneous, because it's not equal to 0, linear differential equation with constant coefficients. We know that to find the solution we need to find the complementary solution, which is the solution to the homogeneous version of the differential equation, and then we need to add on to that a particular solution. So in this case, and going forward, I'm going to give the complementary solution because that was the previous homework assignment was all about finding the complementary solutions. Our focus in this assignment really is going to be how do you find those particular solutions. So we look at the differential equation and we see that the driving term g of x is 2 sine of 2x. And we recognize that derivatives of sines and cosines give us sines and cosines. So what we're going to guess for our particular solution, we're going to guess that it has the form a times the sine of 2x plus b times the cosine of 2x, because when we take a derivative of a sine we get a cosine. We're going to need to include a linear combination of sines and cosines as our solution guess. And then the only thing we need to be careful about is that we're matching the period. So if it's period 2, if it has a period multiplier of 2, so everything's happening twice as fast, the period's actually pi, then we need to have pi as our period, or have that 2 times multiplier here. If we had a combination of a sine and a cosine and they had different periods, we would need to guess linear combinations of both using both periods. And so the idea is, if this is I don't know why I have a prime there, if this is the solution, if I'm guessing that a particular solution has this form, then I want to recognize when I put in the particular solution and its first and second derivative that it needs to be a solution to this differential equation. In other words, when I simplify the left-hand side, it needs to simplify to the right-hand side, to g of x, to the driving term. So we're going to need to take the first and second derivatives of our guess. So taking the derivative of this first term will give me 2 times a times the cosine of 2x. And then the derivative of this one will be minus 2 times b times the sine of 2x. And then we take the second derivative, so we're going to get minus 4 times a times the sine of 2x minus 4 times b times the cosine of 2x. Now the idea is we need to plug the guessed solution and its first and second derivative into our differential equation. So y double prime is going to get replaced with this right here, the minus 4a sine 2x minus 4b cosine 2x, and then it's going to be minus 2 times y prime, so y prime is right here, 2a cosine 2x minus 2b sine 2x, and then close that parentheses, and it's going to be plus 2 times y, and y was our initial guess for the solution form, a sine 2x plus b cosine 2x. And this all needs to add up to the driving function 2 times the sine of 2x. And the idea is we're going to go through and simplify this a little bit by grouping all the sine of 2x terms. So there's going to be sine of 2x terms showing up everywhere. And we can factor out the coefficients on the sines of 2x's. So if I do that, I'm going to get minus 4a times the sine of 2x. And right here, I'm going to get minus 2 times minus 2b is going to be minus plus 4b. So plus 4 times b. And then right here, I'm going to get 2 times a times sine of 2x. So plus 2a times the sine of 2x plus, now we're going to go through and group all of the cosine of 2x terms and then factor out their coefficients so that we get it in a factored form. So minus 4b from here, minus 4a from here, and then 2 times b from here, so plus 2b, and this is times the cosine of 2x, equals, it has to equal 2 times the sine of 2x, and we want to recognize it's really plus 0 times the cosine of 2x. There's no cosine of 2x term showing up. And then we can simplify these a little bit. I have minus 4a plus 2a is going to be minus 2a. So I could replace that with minus 2a. And then here, minus 4b plus 2b is going to be minus 2 times b. Just simplifying those. And then, just like we did in the previous video, now we can equate coefficients. So the coefficient on the sine of 2x term has to match the coefficient on the sine of 2x term here. So I get minus 2 times a plus 4 times b has to equal 2. And from here, the coefficient on the cosine of 2x term, the minus 4a minus 2b, is going to have to add up to the 0 that I see right here. If we multiply equation 1 by 2, or negative 2, we would get, let's see, multiply both sides of this by negative 2. We get negative 2 times negative 2 is 4 times a. Negative 2 times this will be minus 8b equals negative 2 times 2 is negative 4. And then we can add these two equations together. That will zero out the a, so negative 2b plus this will be a negative 10 times b equals negative 4. And then divide both sides by negative 10. It's going to give us b is equal to 2/5. And then we can step over here. I'm going to grab this equation right here. Negative 4 times a minus 2 times b, but b is 2/5, and this needs to equal 0. And then we just simplify. We get negative 4a minus 4/5 equals 0. Add that 4/5 to both sides, and then multiply both sides by negative 1/4. And that'll give us a is equal to negative 1/5. And so our particular solution, we guessed it had this form. So our particular solution is going to be negative 1/5, which is our a, times the sine of 2x plus b, but b is 2/5 times the cosine of 2x. So our solution is going to be y complementary plus y particular. So we take the complementary solution, e to the x times sine times c sub 1 cosine of x plus c sub 2 sine of x plus, and then we add on the particular solution. So negative 1/5 sine 2x plus 2/5 cosine of 2x. And there's the general solution for the differential equation. Had we been given initial conditions, we could then solve for c sub 1 and c sub 2, the constants of integration.